All right, so for this problem, we have the car accelerating. It increases its speed from 0. So velocity initial over here is 0. Velocity final here is 5.2. And then the time in between is 0.832 seconds. Now, here's the thing. The object accelerating is the car, but what we're doing, if you read the question, we're focusing on the guy who's in the car. But since the guy is sitting in the car, you know, what's the guy's initial velocity? 0. What's the guy's final velocity? 5.2, because he's in the car, right? So it's almost like you can erase this car. You can erase the car here and just focus on the guy, right? So the initial velocity of the guy is 0. Erase the car. It's probably more effort than it's worth here. We're focusing just on the dude inside the car. Does that make sense? The initial velocity of the guy is 0. The final velocity of the guy is 5.2. And then they give us the mass of the guy. The mass of the guy is 70 kilograms. So the first question, do you guys remember what magnitude means? Magnitude simply means what? How big, how much, how far. It's the size. And then what's the other thing? So there's magnitude and then direction. And there's magnitude and direction. This just wants the magnitude. Basically, it wants the impulse. What are the magnitudes of the linear impulse and the average force? So we want how big the impulse is and how big the force is. So two questions. First question, we want to find impulse. And then the second question, we want to find the total force.
Or the net force.
Yeah, what's another name for total force?
The summation of the force.
Net force or summation of the forces. Okay, impulse is a fancy name for what? Change of momentum. So how are we going to find the change of momentum? So let's go up here. So number one, there's two possible ways to do it. You could go change of momentum equals momentum final minus momentum initial. You could go that route. Or what's the other way? Change of momentum equals force net multiplied by time. Those are the two equations I gave you for finding impulse. That's this one. What you just said would be this one right here. So basically, this second equation is not going to work because we don't have net force. We do have the time, but we don't have the net force. Okay, so using the first equation there, the impulse, which is change of momentum, momentum final is going to be mvf, momentum initial is mv initial. What's the initial velocity?
0.
0. There is no initial momentum, so the change of momentum is going to be the final momentum. So the change of momentum, we're going to go 70 kilograms times v final, which is 5.2. So the change in momentum of the guy comes out as 364 spaldos.
Yes.
Kilogram meter per second. That's number one. That's the impulse of the guy. It's simply the change of momentum of the guy. All right, second question, how do we find the net force? Well, to find the net force, and keep in mind, this is not the only way you could do it. You could have done this a couple months ago. I could have given you this question a couple months ago and you could have figured it out. But let's do it with momentum. So net force, one of the equations I gave you, net force equals change of momentum over time, right? Do we have the change of momentum of the guy?
Yes.
His change of momentum is 364 spaldos, kilogram meter per second. And then the time that it takes to change the momentum is 0.832 seconds. So this comes out as 437.5 newtons. This right here,
Bam.
that simplifies to newtons.
Ba-bam.
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 Okay? So that's a pretty straightforward problem, right? Hey, what's the other way you could have done this? Like 2 months ago when we were doing forces, you could have solved this by doing a free body diagram. So look, let's make some room. I'll show you, like, you already could have figured this out. Like, so here's the guy. Let's say that this box represents the guy. So there's a net force to the right, like that. So you sum the forces, you know, F net equals MA. So you would have had to have what? Figured out his acceleration. How would you have gotten that acceleration? With a kinematic. VF equals V initial plus AT. V initial is 0. So the acceleration would be VF over T, which is 5.2 over 0.832. So take that acceleration, whatever it is, plug it in there, and you'd get the same answer.